Good afternoon, Louisa. Upon thinking about this, I decided that what you really needed to listen to is a short video presentation by your favorite teacher, Mr. Muscat. So here we go. I'm going to just kind of briefly talk about each of the problems and maybe draw a note, and I don't really know what I'm going to say, but let's give this a shot. I would talk to you tonight at 9 o'clock, but you forget that A, I'm really, really old. 9 o'clock is kind of late. B, it is the eve of Mexican independence, and I may or may not be home, and if I'm not home, I'll probably be in bed. And C, it's Thursday night, and there's football on Thursday nights now. So it's better to do it this way, but I can still talk to you this weekend if need be, or if you just want to chat. Actually, you can call me anytime if you want to chat. But problem number 1 says, which graphs represent functions? Right around October, we did this last year, we had a thing called the vertical line test. If you had a graph, and you had some sort of function, and if you could draw a vertical line everywhere through that graph and only hit one point, it's a function. Why? Because a function is a one-to-one mapping. For every x, for a function, for every x, there is exactly one y. So no matter where I draw my vertical line here, it gets a little close here, but there's only one place I intersect. All right? So for every x, and the x is our domain, and the y is our range. But traditionally we use x and y, so for the domain, x for the domain, y for the range. So when you look at your graph, if at any point you can draw a vertical line and it hits your graph in 2 points or more, problem number 1, 2 points or more, it's not a function, it's just a relation. So if I have a graph and it looks like this, I can draw a vertical line, many places, and I only hit 1 point. But there's also places I hit 2 or more points. Not a function. Not a function. Because for every x, there can be one and only one y. So it's pretty clear that one of the problems in number 1, A, B, C, or D, is not a function. All right? And I don't know how he wants you or she wants you to justify your answer, whether it passes the vertical line test, or for one value of x, there's only one value of y, and for the one that isn't, for certain values of x, or all values of x, almost all values of x, there is 2 y's. All right. Boy, this is a long video if I keep this up. Problem number 2, if I can find it. I printed them off here so I could be intelligent. Oh, we had to do number 4. All right. Problem number 4. Domain and range of some relations are given. Each relation consists of 5 points. Is it a function? Explain. So if I had the domain is the set 4, 5, and 6, and the range is the set 3, then I have, if x is 4, for x is 4, there's only one choice here, 3. X is 5, there's only one choice. If x is 6, there's only one choice. All right? So clearly, if the domain is this would be a function. I'm actually a little perplexed by the question, I guess. The domain and range are given. Each relation consists of 5 points. I didn't read it carefully. 5 points. Is it a function? Explain. So let's redo this. Let me erase this. Here's my first point, or my first example. There's 5 points, all right? My domain is 4, 5, 6, 7, and 8. That means my 5 points, I have the ordered pair 4 something, 5 something, 6 something, 7 something, and 8 something. Now, 4 could be 2 or 3, 5 could be 2 or 3. For instance, it could be 2, 3, 3, 3, 3. All right? I don't know how many times 2 is used. I don't know how many times 3 is used. But when x is 4, there's one and only one value of y. There's no other option. All right? 4 is used once, 5 is used once, 6 is used once, 7 is used once, 8 is used once. And I have 2 choices here, but when x is 4, it's either 2 or y. When x is 5, it's either, 2 or 3. When x is 5, it's either 2 or 3, 6, 2 or 3, 7, 2 or 3. So there's never a case where you have x is 1, 2, 3, 4, and y is 1, 2, 3. I never have the ordered pair 4, 2, and 4. Try this again. Obviously, I never have the case where I have the ordered pair 4, 2 and 4, 3. That wouldn't pass the vertical line test. If I tell you that there's a certain x, there's one and only one y. This doesn't happen, it would be a function. But if I switch these around, all right, if I said my domain, we're going to just move this, domain and range. All right, I switched them. So if my domain is 2, there's 2 or 3, and my range is 4, 5, 6, 7, and 8, I don't know how many times 2 is used, but at a minimum, since there's 5 points, one of them is used multiple times. So I have 2, 3, 2, 2, and 2. So when I have 2, I could have 4, and 3, I could have 5, and I could have 7, could have 8, and what haven't I haven't used 6. So because I only have 2 choices for 2 and 3, I'm sorry, for the first coordinate, I have 2 choices, 2 and 3. The other points, I'm going to have, how am I trying to say this? when x is 2, I can have only one answer. And here I have 4 different answers. And even if I had made this 3, but when x is 3, I can only have one answer. Here I have 2. I have to use the x-coordinate of 2 or 3 or both multiple times, so it's not a function. When x is 2, I can only have one y. When x is 3, I can only have one y. In this case, I have multiple. So when you look at them, can you arrange them so that there's, for every x, there's one and only one y? Then it's a function. But if there's any way that you can arrange them, when for one x, there's more than one y, it's not a function. And so, there's a couple of them that are not functions. All right. Ooh, that one was harder than I thought. All right. Let me pause this. All right. Number 5 is hopefully will be pretty easy because I'm running out of minutes here on my account. For number 5, it says state the domain and range. Well, look at the graph. And we did this where we kind of slid a piece of paper across to see where we were hitting x's. But if you have a function like this, 1, 2, the domain would be x greater than or equal to 2. The range is all reals. And I'm not sure the form that you're using to state this. If I look at a function like this, try it again. If I look at a function like this, a parabola, and this is 1 and 2, the domain is all reals. The range, the smallest number the range is 2. The range is y greater than or equal to 2. All right? So that's all the domain and range are. We did this, again, when we talked about functions and domain and range. These look pretty straightforward. Problem number, letter E, you have 2 asymptotes. So in the domain, there's a place that x is never equal to, and in the range, there's a place x is never equal to. So if I gave you a problem like this, and my graph looks like this, here I have an asymptote at the x and y axis. This is actually y equals 1 over x if x is greater than 0. The domain would be x greater than 0, and the range would be y greater than 0, because I have an asymptote here and here. And lastly, number 8, number 7, I am going to have to do this in a separate video because I can only upload things that are 15 minutes. Poor you having to listen to this.